So before we get into verifying trigonometric identities, we first have to go through a list of formulas. But before we have to do that, let's go over some prerequisites that you should know before getting to verify trigonometric expressions. So you should have some basic knowledge of some basic trigonometric equivalencies. So for example, you should know your reciprocal functions. So for example, secant x is equal to 1 over cosine x. You should know functions like that. In addition, you should also know your quotient functions. You have, so for example, tangent x is equal to sine of x, cosine of x. You should know that as well. And last, you should know that on the unit circle, sine of x is equal to y, and cosine of x is equal to x. So the most important functions that we're going to use, or identities that we're going to use to verify trigonometric expressions, are the Pythagorean identities. So the first one is sine squared x plus cosine squared x is equal to 1. Now, how do we get that? First, let's draw the unit circle. This dot is the center, and we're going to draw right triangle from this unit circle. So we know that this hypotenuse leg here has a length of 1, since it corresponds to the radius of the unit circle, and the radius of the unit circle is just 1. We also know that this leg is equal to cosine of x. We know that this leg is sine of x. Now we can use the Pythagorean theorem to derive the first Pythagorean identity. So the Pythagorean theorem is a squared plus b squared is equal to c squared. So for a squared, we're just going to do sine of x. It doesn't really matter. We're just going to plug in sine of x for a. So we have sine of x squared plus cosine of x next for b, cosine x squared is equal to 1 squared, which is just 1. And you can already see it coming together. So sine of x squared is also known as sine squared of x. And then cosine x squared is just cosine squared x. And that's what that is. Let me just erase all this real quick. So there's 2 other Pythagorean identities. We can derive this second one by dividing both sides of this first identity by sine squared of x. By sine squared of x. So what's sine squared of x divided by sine squared of x? That's just 1. Okay. So what's cosine squared of x divided by sine squared of x? Well, we know that cotangent of x is cosine of x over sine of x. But since it's squared, it has to be cotangent squared of x. and 1 over sine squared of x is equal to cosecant squared of x. And that's our third identity, or second identity. We can derive the third Pythagorean identity similarly. So instead of dividing the first Pythagorean identity by sine squared of x, let me do this in a different color. Instead of dividing it by sine squared of x, I'm going to do cosine squared of x. What's sine squared of x divided by cosine squared of x? That would be tangent squared of x. What's cosine squared of x divided by cosine squared of x? That would just be 1. And then 1 over cosine squared of x is secant squared of x. And that's our third identity. There's some other ones other than the Pythagorean identities that you need to know that I'm not going to cover in this video. But these are the most important functions, or rather equations, that you're going to see when you're verifying trigonometric equations. So some tips that you're going to need when you're verifying trigonometric identities. The first one, and excuse my handwriting, it's kind of bad, is you always want to condense a side into one term. The second tip is that you want to look for any opportunities to factor first. The third tip is plus and minus are signals to convert a term into a fraction using a variation of 1. That doesn't make sense right now, but it'll make sense later. The fourth one is if you see a fraction and it doesn't have the same denominator as another fraction, use a variation of 1 to make the denominators the same. And then the last tip is to convert all functions into sine and cosine. Hopefully my handwriting isn't that terrible. Hopefully you can read that. But I said it all, so it should be fine. But those are the tips you need before solving trigonometric identities. So here's our first problem. We have cosine of x times tangent of x is equal to sine of x. We're going to start out pretty simple. So the first thing we should do is turn this tangent of x into sines and cosines. So we have cosine of x times sine of x over cosine of x is equal to sine of x. Now we want to convert the left side into one term. And we can do that easily since there's a multiplication sign. So cosine of x times sine of x over cosine of x is cosine of x times sine of x over cosine of x. And that's equal to sine of x. Now, since there's a cosine of x in both the numerator and denominator, they cancel out. So all we're left with is sine of x, which is what we have on the other side of the equation. So here's our second problem. We have cosecant of x minus sine of x is equal to cotangent of x times cosine of x. So the first thing that we should do is convert everything into sines and cosines. So we have cosecant of x, which is equal to 1 over sine of x minus sine of x is equal to cotangent of x, which is equal to cosine of x over sine of x times cosine of x. So now we're going to combine both sides of the equation into one term. So we can do the right side pretty easily since there's a multiplication sign. So cosine of x over sine of x times cosine of x is just cosine squared of x over sine of x. Now I'm going to write the left side of the equation. So for the left side of the equation, we can't combine both terms into one term that easily like the right side of the equation, since this time we're minusing instead of multiplying. So what we're going to do, so since there's a minus sign, we're going to use a variation of 1 to turn a term into a fraction. So since 1 over sine of x is already a fraction, we don't need to do that. We're going to do that to sine of x. So we're going to multiply sine of x by sine of x over sine of x. And we can do that because sine of x over sine of x is just 1. Sine of x divided by sine of x is just 1. So technically, sine of x times sine of x over sine of x is still equal to sine of x. So we have 1 over sine of x minus sine squared of x over sine of x. And now that these two have the same denominator, we can combine it into one term. So we have 1 minus sine squared of x over sine of x is equal to cosine squared of x. Okay, so right now it seems like we can't do anything else, but this is actually a Pythagorean identity that's equal to something. So we're gonna go over here. So I showed you 3 Pythagorean identities, and this didn't show up. But we can derive this from one of the Pythagorean identities. So recall that sine squared of x plus cosine squared of x is equal to 1. Then we can subtract sine squared of x from both sides to get cosine squared of x is equal to 1 minus sine squared of x. This is the same as that. So we can substitute 1 minus sine squared of x for cosine squared of x. So we have cosine squared of x over sine of x, which is the same on the other side. So we have verified this identity. So here's our next problem. We have 1 minus sine of x times 1 plus sine of x is equal to cosine squared of x. So what we can do is this is a factor form of a quadratic. So what we can do is just expand this. So we're going to do that by FOILing. So we're going to do 1 minus sine of x plus sine of x times 1 minus sine of x. So 1 times 1 is just 1. 1 times negative sine of x is just sine of x. And then sine of x times 1 is just sine of x. And then sine of x times negative sine of x is negative sine squared of x. So negative sine of x plus sine of x is just 0. So what we're left with is 1 minus sine squared of x is equal to cosine squared of x. If you remember this from the last problem, that's equal to cosine squared of x, which is the same on the other side, so we verified this identity. So here's our next problem. We have secant to the fourth x minus tangent to the fourth x is equal to 1 plus 2 times tangent squared of x. So always remember that you want to look for factors to opportunities to factor first. So since this is just a difference of squares, we can just factor this as secant squared x minus tangent squared x times secant squared x plus tangent squared x. And then, okay. So this is equal to something based on our Pythagorean identities. So recall that 1 minus tangent squared of x is equal to secant squared of x. Or excuse me, this should be a plus. So if we subtract both sides by tangent squared of x, we're left with 1 is equal to secant squared of x minus tangent squared of x. So secant squared of x minus tangent squared of x is just equal to 1. So it's 1 times secant squared of x plus tangent squared of x. So 1 times a number is just that number. So we're just left with secant squared of x. Where should I write this? I'll just write here. You're just left with secant squared of x plus tangent squared of x is equal to 1 plus 2 times tangent squared of x. Okay, so I'm kind of stuck right now. So what we're gonna do is convert everything into sines and cosines. So secant squared of x is equal to 1 over cosine squared of x. Tangent squared of x is sine squared of x is over cosine squared of x. Sine squared of x over cosine squared of x. And then we have tangent squared again, so it's sine squared of x over cosine squared of x. So since these two on the left side have the same denominator, we can convert it or just condense it down into one term. So you have 1 plus sine squared of x over cosine squared of x. Okay, next we're going to distribute this 2 into sine squared of x over cosine squared of x. So we have 1 plus 2 sine squared of x over cosine squared of x. I'm going to transfer over to this left side here. So on this right side of the equation, we want to condense it down to one term, but we can't really. So what we're going to do is turn this 1, we're going to multiply 1 by a variation of 1, so we can get the same denominator as this term. So to get the same denominator as that term, we're going to have to multiply 1 by cosine squared of x over cosine squared of x. Let me just write the rest of the equation real quick. We're going to multiply cosine squared of x over cosine squared of x by 1, which is just cosine squared of x over cosine squared of x plus 2 sine squared of x over cosine squared of x. Now we can condense it down into one term. So we have cosine squared of x plus 2 times sine squared of x over cosine squared of x. Let me write down the left side of the equation. Could write that better, but it's okay. So right now it seems like we're stuck, but if we rewrite 2 sine squared of x as something different, then we're gonna get our answer. So we can rewrite 2 times sine squared of x as running out of space. We can rewrite 2 sine squared of x as sine squared of x plus sine squared of x. Since multiplication is just repeated division, or multiplication is just repeated addition. And then this looks familiar because that's one of our Pythagorean identities. So cosine squared of x plus sine squared of x is just 1. So we have 1 plus sine squared of x over cosine squared of x, which is the same on the other side. It's a little messy, but there we have it. So this is our next equation. We have secant squared of x plus secant squared of x times tangent squared of x is equal to secant to the fourth x. So what we can do for this left side is factor out the greatest common factor. So since both of these terms share secant squared of x, we can factor out secant squared of x. So secant squared of x is outside of the parentheses. Okay, so secant squared of x divided by secant squared of x is just 1, plus, then secant squared of x times tangent squared of x divided by secant squared of x is just tangent squared of x. This is familiar because this is a Pythagorean identity. So recall that 1 plus tangent squared of x is equal to secant squared of x. So 1 plus tangent squared of x is equal to secant squared of x. So we have secant squared of x times secant squared of x is equal to secant to the fourth x. Secant squared of x times secant squared of x is equal to secant to the fourth x based on exponent properties. So we have secant to the fourth x, which is the same on the other side, so we've verified the identity. So here's our next problem. We have secant of x over sine of x minus sine of x over cosine of x is equal to cotangent of x. So on the left side, we have two fractions, but they don't have the same denominator. It'd be really nice if we had a common denominator. So what we're going to do is we're going to multiply both of these fractions by a variation of 1. So we're going to multiply secant of x over sine of x by cosine of x over cosine of x. And then we're going to multiply sine of x over cosine of x, sine of x over cosine of x by sine of x over sine of x. So cosine of x times secant of x is just 1, since secant x is the reciprocal of cosine of x. So that means it's just 1. And then cosine of x times sine of x is just cosine of x times sine of x. And then we have sine of x times sine of x, which is just sine squared of x. And then we have cosine of x times sine of x. Now we can condense it down into one term. And then while we're at it, we're just going to convert cotangent of x into sines and cosines. So cotangent of x is equal to cosine of x over sine of x. 1 minus sine squared of x is equal to cosine squared of x. Then we have cosine of x times sine of x. And then since we have cosine in both the numerator and the denominator, these cancel out. But since the numerator is cosine squared of x, we're still left with cosine of x on the numerator. So we have cosine of x over sine of x. Cosine of x is gone because it's not squared on the denominator. which is the same as the other side of the equation. So here's our final equation. We have 1 over 1 minus sine of x is equal to secant squared of x plus secant of x times tangent of x. So we can factor out the greatest common factor on the right side of the equation. So we just have secant of x. We can factor out secant of x since both terms on the right side of the equation is just secant of x. I have secant of x. So it's secant of x outside. Secant squared of x divided by secant of x is just secant of x. Then secant of x times tangent of x divided by secant of x is just tangent of x. Now what we're going to do is convert everything to sines and cosines. So we have 1 over cosine of x, over cosine of x again, and then sine of x over cosine of x. We can combine this into one term. So it's just 1 plus sine of x over cosine of x. And then we can multiply this. So 1 over cosine of x times 1 plus sine of x over cosine of x. It's just 1 plus sine of x over cosine squared of x. Then let me write the rest of the equation. So we have two fractions that don't have the same denominator. So we're going to use a multiple or a variation of 1 to have them have the same denominator. So we can verify this easier. So we can multiply 1 over 1 minus sine of x by cosine squared of x. And then we can multiply 1 plus sine of x over cosine squared of x by 1 minus sine of x over 1 minus sine of x. So cosine squared of x times 1 is just cosine squared of x. And then cosine squared of x times 1 minus sine of x is just that. And then 1 plus sine of x times 1 minus sine of x. We can FOIL this out quickly. FOIL this out quickly. So you have 1 minus sine of x plus sine of x, 1 minus sine of x, running out of space. Rewrite this. 1 times 1 plus sine of x minus sine of x, 1 plus sine of x. 1 times 1 is just 1. 1 times sine of x is just sine of x. Negative sine of x times 1 is just negative sine of x. Then negative sine of x times sine of x is negative sine squared of x. These cancel out, so we're just left with 1 minus sine squared of x. Over cosine squared of x, 1 minus sine of x. And then 1 minus sine of squared of x is equal to cosine squared of x. So we have, gonna move over here. I think I have enough space on the bottom. I have no space there either. Move over there. I'm gonna write the left side of the equation. And then 1 minus sine squared of x is cosine squared of x. So both these sides match. And we've verified the identity. And whatever, you know that they have both have the same denominator. We've verified the identity.